Hello students. So today we will do some theorems on graph theory. I know theorems seem boring to you all, but when you will start to see beauty in theorems, you will love them. Remember one thing, never cram a theorem. Always understand the logic and application behind any theorem. They will become very easy for you. Okay, so let's start. So first theorem on graph theory is the handshaking theorem. What does this theorem says? This theorem says that the sum of the degrees of all the vertices in the graph is equal to twice the number of edges in G. That is, summation degree of Vi is equal to 2 times the edges. So let's see what does this theorem says with the help of one example. So let's count the degree of all the vertices here. If you see the degree of first vertex 1, it is incident by 2 edges. So degree of vertex 1 is 2. Degree of vertex 2 is 1, 2, 3. Degree of vertex 3 is 1, 2. Degree of vertex 4 is 1, 2, 3. Degree of vertex 5 is 1 and 2. Degree of vertex 6 is 2. Okay, so I have written degree of all the vertices here. If you add them up, you will get a sum of 14. Okay, you will get 14 as a sum. And if you look at the edges here, how many edges are here? First edge, second edge, third edge, fourth, fifth, sixth, 7 edges. So 7 into 2 is again 14. So sum of degree of all the vertices is also 14, and 2 times the number of edges is also 14. So sum of the degree of vertices is equal to 2 times the number of edges. Okay, so this theorem holds for all the graph. Okay, so what's the basic concept? Before proving this theorem, we will understand the basic concept of this theorem. The basic concept behind this theorem is that degree of vertex depend upon edge connected to it, and each edge contribute to 2 degrees. Alright, so if there is no role of vertex in degree, okay, the main role is of the edge. If I add one node here, if I add one vertex here, there is no change in the degree of any vertex. Okay, but if this node is attached with the graph by this edge, then the sum of the degree of all the vertices will be increased by 2, because here 1 degree because of this one, and 1 degree will increase because of this one. So one edge contribute to 2 degrees in a graph. Okay, so main role is of edge. Okay, so let's prove this theorem. Let E be any edge in the graph between 2 vertices V1 and V2. Now when we count degree of all vertices, E is counted twice. Okay, once in degree of V1 and again in degree of V2. Okay, if I have edge E, okay, and this is V1 here and V2 here, so E is contributing once with the degree of V1 and E is contributing 1 with the degree of V2. Okay, also if V1 and V2 are identical, again E will be counted twice. Okay, if V1 and V2 are identical, if suppose I have this V1 which is equal to V2, then this will be my E will be loop. Okay, this will be my E. Again, for a loop, we count the degree 2 times. Okay, degree is added by 2 number when there is a loop. Okay, so each edge is contributing 2 times in the sum of the degree of all the vertices. So every edge is counted twice. So if there are 3 edges, okay, then each edge is being counting 2 times. So 2 plus 2 plus 2, it is 3 into 2. If there are 4 edges, 2 plus 2 plus 2 plus 2, 4 times, 2 into 4. So if there are 5 edges, there will be 2 into 5. If there are 6 edges, 2 into 6, and so on. So if there are e edges, if their total number of edges are e, so it will be 2 times into each. So sum of the degree of all the vertices in the graph will be 2 times the total number of edges. Okay, so this proves our theorem. Okay. So why this theorem is called handshaking theorem? Because if we consider vertices as people and we consider edges as handshake, okay, and if everybody counts how many times they have shaken hands, then the grand total will be twice the number of handshakes. Okay, so there are twice as many hands shaken as handshakes. Okay, so 2 times the total number of edges, 2 times the number of handshakes is equal to the degree of all the vertices, means the number of handshakens. Okay, handshakers. So that's why this theorem is called handshaking theorem. The second theorem is prove that in a graph the number of vertices of odd degree is even. So if you consider any graph, then the total number of vertices of odd degree is always even. If you see in this graph, degree of vertex 1 is 3. Okay, degree of vertex 2 is also 3. Degree of vertex 2 is 2 and degree of vertex 4 is 2. So number of vertices of odd degree are 2. There are only two vertices whose degree is odd. Suppose if I add another vertex here. Okay, if I add another vertex here, let me add one vertex here. So now how the degree is changed, I will name this vertex as vertex 5. So degree of vertex 1 is 3, which is odd, so I'll write all the odd degree vertices here. Degree of vertex 2 is 3. Okay, 2 also has odd degree. Degree of vertex 3 is also odd, so 3 also has odd degree. Degree of vertex 4 is 2, so I'll not write there. And degree of vertex 5 is 1, which is again odd. So how many total number of vertices are there whose degree is odd? There are four vertices who has odd degree. So there are even number of vertices who have odd degree, because 4 is an even number, so there are even number of vertices which has odd degree. Suppose if I add 5 here, if I am adding the vertex 5 at this point, now if I see odd number of vertices, so 1 has odd degree. Okay, 5 has odd degree. 2 doesn't have odd degree. 3 doesn't have odd degree. 4 doesn't have odd degree. So okay, 1 2 3 4, right? So this is also even. So how many vertices are there which has odd degree? So there are 2 vertices which has odd degree. So again, even number of vertices have odd degree. So it's always true that the vertices whose degree is odd are even in number. So let's prove this theorem. Let E be the edges and n vertices are there in the graph. Okay, and with E edges, since each edge is incident on 2 vertices, it contributes to the sum of degree of vertices in a graph. The sum of degree of all the vertices in G is twice the number of edges in G. We have this result by first theorem. Okay, so now what I am going to do, I will divide my vertices into 2 sets. One which have odd degree and one which have even degree. Okay, so let the degree of first r vertices be even and the degree of remaining n minus r vertices be odd. Then clearly, because each this term degree of Vi is even, so summation will be also even, because sum of even numbers is always even, right? So this term will be even. We can write summation degree of Vi equal to degree of Vi, where the summation is running from 1 to R and this summation is running from R plus 1 to N. Okay, because I have divided the set of vertices into two parts. One, the first R, which has even degree, and remaining N minus R vertices has odd degree. Okay, so this thing, I can write this summation into two parts. Now, I have taken this term the other side. Now here this thing is even. Why this thing is even? From here you can see this is 2 times E, so this is even. Okay, this term is also even. Okay, because I have just explained you that sum of even numbers is even, so this thing is also even. So even number minus even number will give me a even number. Okay, so this gives me that degree of summation running from R plus 1 to N, degree Vi will also be even. So this thing will be also even. Okay, and each degree Vi is odd. Okay, because this summation, we have taken this summation for the odd degree, so each degree Vi is odd, and odd number into something equal to even, which it means that something is even, right? So if I take this 3 into x equal to 60, so 3 is odd number, x I don't know, 60 is even number, so this x will be 20, which is even. Okay, when I'll solve this x must be even. So the sum of the degrees, the number of terms here, should be even. Okay, so the total number of vertices with odd degree must be even. Okay, so for each Di is odd, so the number of terms in this summation must be even. Okay, so third theorem, prove that the maximum degree of any vertex in a simple graph having n vertices is n minus 1. Okay, so let's understand this theorem. If you'll see the degree of 1, okay, because it's a simple graph, so this thing is not possible, right? Loop is not possible, loop will not be there. Okay, and there will be no parallel edges. This thing is also not possible. These two things are not possible here. So this vertex can be attached to 2 in one way only. Vertex 1 can be attached to 3 in one way only. Okay, and vertex 1 cannot be attached to itself, because in a simple graph there is no loop. Okay, so if I have 3 edges and if I look for the maximum degree of 1, then it can be 3 minus 1 only, which is 2. Okay, similarly for 2 also, it will be the maximum degree of vertex 2 will be 2, the maximum degree of vertex 3 will be 2. So if there are n edges, so maximum degree of any vertex will be 1 less, okay, than the total number of vertices. So let's prove this theorem. In a simple graph, there are no loops and no parallel edges. Okay, let v1, v2, vn be vertices in a graph. As G is simple, v1 can be connected to v2, v3, vn, but cannot be connected to v1 because there are no loops. As I have explained you here, that this vertex 1 can be connected to 2, 3, but it cannot be connected to itself, because in a simple graph there are no loops. Okay, so v1 can be connected to v2, v3, vn, but cannot be connected to v1 because there are no loops. Okay, also if v1 is connected to any vertex vi by any edge e, then there cannot exist any other edge between v1 and vy, because there are no parallel edges. Okay, so as I have explained you here, 1 can be connected to 2, 1 can be connected to 3 in one way only. Okay, there cannot be any parallel edge between these things. So 1 can be connected to the other edges in 2 ways here. So in a graph which has n vertices, first vertex can be connected to remaining n minus 1 remaining n minus 1 vertices in n minus 1 times. So V1 is connected to any Vi by an edge E, then there cannot exist any other edge between V1 and Vi because there are no parallel edges. So V1 can be connected to other vertices by at most n minus n edges. Maximum there can be n minus 1 edges. There cannot be more than n minus 1, but there can be less than n minus 1. Okay. So hence maximum degree of any vertex in simple graph having n vertices is n minus 1. So this clearly proves that maximum one vertex can be connected to n minus 1 only, n minus 1 vertices only. Okay, it cannot be connected by any other vertex 2 times. It cannot be connected to itself by a loop. So maximum degree which a vertex can have is n minus 1 only. So this proves theorem 3. Now let's move to theorem 4. Show that the maximum number of edges in a simple graph with n vertices is n into n minus 1 divided by 2. So let's take V1, V2, Vn be n vertices and E1, E2 to E be E edges in a simple graph. Then by first theorem we know degree of Vi is equal to 2 times degree of E. Okay. Also we know that in a simple graph the maximum degree of any vertices with n vertices is n minus 1. The previous theorem, the third theorem, we have just seen this, that in any simple graph the maximum degree of any vertex with n vertices is n minus 1 only. So the maximum degree of n vertices is equal to n minus 1, so on to n minus 1. These are the n terms. These are n terms. Okay. So this summation comes out to be n into n minus 1 because we are considering n terms. So this summation comes out to be n into n minus 1. Okay. So the maximum degree. So the sum of the maximum degree of n vertices is n into n minus 1. So summation degree Vi will be less than or equal to n into n minus 1 because the maximum one is this. So sum of the degree of Vi can be less than or equal to the maximum thing. Therefore, from equation 1, 2 times from this equation, if you put degree of Vi equal to 2e here, you'll get 2e less than equal to n into n minus 1. So e is less than equal to n into n minus 1 divided by 2. So therefore, the maximum number of edges in a simple graph with n vertices is n into n minus 1 by 2. Okay. So now the last theorem is prove that the number of edges in a complete graph with n vertices is n into n minus 1 by 2. What is a complete graph? A complete graph is that graph in which all the vertices are attached by an edge with each other. Okay. So every vertex in a complete graph is joined with every other vertex through one edge, and degree of every vertex in a complete graph of n vertices is n minus 1. So summation of degree of Vi is equal to n into n minus 1. And by first theorem, degree of Vi is equal to 2 times E. So let's put this here. So 2 is equal to n into n minus 1. So E is equal to n into n minus 1 by 2. N into n minus 1 by 2. Okay, so this was quite easy. You could have understood it. So n into n minus 1. So this proves the theorem. Okay, so thanks for watching this video. I hope you have understood all the theorems. If you have any doubt, you can text me, you can message me. Have a great day ahead. Thank you.